Hello everyone. In this session, we'll see a question on Runge-Kutta method, which is about the numeric solutions of differential equations. So it says, for a differential equation given by, let's say, y dash equal to y minus y square, if y of 0 is 0.2 with step size of 0.1, the increment in y calculated using Runge-Kutta fourth order method. Of course, fourth order, we have studied that. Fourth order method is how much? So we have this function of x, y. This is nothing but function of x, y. Step size is also given. This is h. This is y at 0. So this is y naught. Right? We have three variables which is required. Now what they are looking for is the increment. So we know that since we are starting with y naught, we know that yn is given as y naught plus k. So that means yn minus y naught is simply k, and this is the increment we are looking for. This is the increment we are looking for. So what is k? K is given by 1 by 6 times of k1 plus k2 2k2 plus 2k3 plus k4. We have seen what are these auxiliary terms and the formula for these expressions. So let's calculate it. Let's start with k1. K1 is simply given as h times of f of x naught comma y naught, and we know that this function is given as y minus y naught or y square, y minus y square. So this becomes h is equal to 0.1, so this becomes 0.1 into this y at 0 is given as 0.2, so this is going to be 0.2 minus 0.2 square. Yes, 0.2 minus 0.2 square, which is 0.016. Now we have to find k2. K2 is h times of function at x naught plus h by 2 and y naught plus k1 by 2. So what is y naught? Y naught is 0.2. Now h is 0.1. So we can clearly see that this function has only y variables. It has no x variables. That means whatever value we are going to put here, it won't change the values. We are only depending on this y or y naught plus k1 by 2 or whatever values we are coming for y. So this is going to be 0.1. So what is this function? Let's see. This is 0.2 plus 0.1 by 2. Oh sorry, 0.016 by 2. Let's see what is this value. This value is going to be 0.2 plus k1. So let's write it here. 0.2 plus 0.016 by 2, and this is going to be 0.208. So this is going to be 0.208 minus 0.208 square, and this is 0.0164. Now K3 is h times of function at x naught plus h by 2 and y naught plus k2 by 2. So let's see what is k2. What is this term? This is 0.2 plus k2, 0.0164 divided by 2. This is going to be 0.2082, which makes this value to be 0.1, 0.2082 minus 0.2082 square, and this is 0.01648. So we have reached up to K3. Now we need K4. This K4 is given as h into function of xn plus h and yn plus k3. So what is this value now? This is y naught, which is 0.2 plus k3. We have found k3 and it is plus 0.01648. So this is 0.21648, and this is going to be 0.1, 0.21648 minus 0.21648 square. This is 0.01696. So finally we can find this k. This k is 1 by 6 k1 plus 2k2 plus 2k3 and k4. One by 6, k1 is 0.016 plus 2 times of, let's take it in common, k2, which is 0.0164 plus k3, which is 0.01648 8 and plus K4 which is 0.01696. This value comes out to be 0.01645. So this is the increment. I'll say it as del y or simply k. Also we can find y1. y1 is y0 plus k. So this is 0.2 plus 0.01645 which will be 0.21645. If required we can find y1 also. That's it.